Okay, in this video, we convert our heat map into an isoline map, and that really is just a process of classifying it. And so we have our point density map of points of interest, otherwise known as a heat map of points of interest here. And we go ahead and right click it and then go to symbology. And so right now it's stretched, so it's just showing a continuous color spectrum. Uh, the colors vary by grid cell based on the unique value in that grid cell. And we're going to go ahead and simplify this and classify it. Um, and I'm not going to spend much time on the color necessarily, but you can change the color. It should be just one color varying from light to dark. And the natural breaks provide these classes where it minimizes differences within the class. So they're kind of bunched up. The numbers are kind of bunched up in these classes. And so you can always use those break values as a starting point and then kind of round them so that way they're not these weird numbers here. And that would be then a manual classification, but you've been informed by the natural breaks. So that's kind of why the software starts off with that. If you wanted to use other forms of statistics to create the classes, you could use quantile, which would break up the surface into equal parts. So like four equal parts would be quarters, where each class, a quarter of the grid cells would be in each class. Or if you use five classes, it would be 20% of the grid cells are in each class. The equal interval would be like, splitting it up into classes of, say, 1 point per square mile. And then, each class would be a range of one. So it'd go 0 to 1, 1 to 2, and so forth. And then standard deviation would be if you had a normal distribution, then you could show classes that are above or below the average. So by standard deviation, so it'd be like, you're around the average, you're within a standard deviation of the average, and then you have those that are greater than that and less than that. Um, but for our purposes here, we're just going to go ahead and use manual based on our natural breaks, 1.5 or sorry, zero point 0.5, 1.5, 3, and 6. Okay. And so here is our isoline map. And the points, you could keep them on the map just to illustrate the pattern that the heat map is accentuating. You might just change the symbols to something a little bit more simple without the outline. Let's see, I'll just use circle one and definitely make it smaller. So that's just kind of like a shadow of what this surface is based on. Basically, it's just showing kind of like how that surface was derived with the original point pattern in the map. And so that, yeah, something like that is perfectly fine. And then you can go about, creating a layout with legend and so forth to construct this ISO line map.